Hi guys, welcome to our last chemistry video. This week we're talking about chemical reactions some more, and specifically the law of conservation of mass. So we already talked about what a chemical reaction is, same thing as a chemical change. It's when the substance that you're using becomes a new substance or becomes broken apart and can't be reversed. This is different than a physical change. Which is when the form changes but the identity of the substance is still the same. Chemical equations are used to show chemical reactions. So down here is an example of a chemical equation. This is carbon plus oxygen makes carbon dioxide. Really important that you know that the reactants are what's put into the reaction. So they're on the left in this situation, and the products are what's produced, what comes out. In this situation, they're on the right. Usually the reactants are on the left and the products are on the right, but there are situations where the arrow points the opposite direction, and then of course the reactants and the products would be switched. Also important to know that the word yields is used in chemical reactions. So when you're saying a reaction, you would say carbon plus oxygen yields carbon dioxide. It's just a little more scientific and a little more accurate than saying makes or produces. So at the very beginning of this unit, when we were talking about matter, we talked a little bit about how matter is never created or destroyed. And that's true in chemical reactions also. It's called the law of conservation of mass. And it just says that in a chemical reaction, mass is neither created nor destroyed, and that's true in the whole universe. So the mass of the reactants is equal to the mass of the products. No matter is created, no matter is destroyed. A new substance is created, but that is just recombining the atoms that already were there into a new substance. Here's just an example of that. If you have 2 grams of sodium and 1 gram of chlorine, then you have to have 3 grams of sodium chlorine because you have 3 total grams on this side and 3 total grams on this side. So you can think of this, this arrow as an equal sign where you need both sides to be balanced. You could think of it as a scale also. Basically, what goes in has to come out. So this is true not only for mass, like grams or kilograms or pounds, it's also true for atoms. So if you have 2 atoms of oxygen on one side, you have to have 2 atoms of oxygen on the other side. The scale has to be equal. Even if one thing is escaping into the atmosphere as a gas, it's still written in the products. It's still going somewhere. It's just in a different form. It's important to be able to tell how many of each atom is in your equation or reaction. So if you look here, this says 5H2O. There are 2 types of numbers here. One is the coefficient and one is the subscript, excuse me. So the coefficient is this big 5. It's the leading number. It'll be a full-size number, same size as the letters. That tells you how many molecules there are. So that 5 is telling you that there are 5 water molecules. The little 2 is called a subscript. And that tells you how many of each individual atom there is. So there's 5 molecules of water, and there's 2 molecules of hydrogen in each water molecule. So total, I would multiply, and there would be 5 oxygens and 10 hydrogens, because 5 times 2 is 10. Also important that if there is no coefficient, then you assume that the coefficient that's there is 1. Okay, so let's practice. Pause the video and see if you can figure out the number of atoms that are in each of these molecules. Then when you're done, press play again and see if you got them right. Okay, go ahead and check your answers. So in this carbon dioxide, there are 6 carbons because this 6 goes with this 1 C. And there's 12 oxygens because 6 times 2 is 12. In this salt, there's 4 sodiums, Na is sodium, and 4 chlorines, Cl is chlorine, because there are no subscripts. In this ammonia, there's 3 nitrogens because that has a subscript of 1. It's assumed 1. And 12 hydrogens because 3 times 4 is 12. And in this glucose, 12 carbons multiply, 24 hydrogens multiply, and 12 oxygens multiply. So there's 2 glucose molecules, but there's a lot more atoms than that. Sometimes in order to get your number of atoms on the reactant side to equal your number of atoms on the product side, you have to add some coefficients, and that's called balancing the equation. To do that, you only can change the coefficients. You never change the subscripts, because if you change the subscripts, you're changing the whole identity of the molecule, and you don't want to do that. You just want to change the number of molecules that there are. So never, never, never change the small numbers, only add big numbers. To know that your equation is balanced, you need to have the same number of each type of atom on each side. So if you have 3 oxygens and 4 hydrogens on one side, you need to have 3 oxygens and 4 hydrogens on the other side. They have to be the same. So here's an example equation. This is saying hydrogen plus oxygen yields water. On the reactant side, which is here to the left of the arrow, there are 2 hydrogens and 2 oxygens. I got that from the subscripts on each of them. There are no coefficients, and so I don't do any multiplying. On the product side, there are 2 hydrogens, but only 1 oxygen. So this equation right now is not balanced because whatever you put in is not coming out. So to do this, we add add balanced. In order to balance it, we'll have to add coefficients to each number so that they become the same. So the first thing I'm going to do is I'm going to get my oxygens up to 2. So to do that, I'm going to add a coefficient of 2. Now I also have to change my hydrogens because I need to multiply the subscript 2 and the coefficient 2. So that will give me a total of 4 hydrogens. Now on this side, the oxygen is good, but the hydrogen needs to be increased. So I'm going to add a 2 coefficient here, so that when I multiply, I get 4 hydrogens. I can assume that the coefficient for the oxygen is a 1. I actually don't even have to write that 1, but I'm writing it so that everyone is clear that it's there. Now this is balanced because 4 hydrogens went in, 4 hydrogens came out, 2 oxygens went in, 2 oxygens came out. All right, pause your video, try balancing these equations, and then check back when you're finished to see if you got the right answers. Okay, see what you got. Remember, the blank spaces are assumed to be 1s. One thing I do want to highlight is that sometimes you might see elements in parentheses, like this one, and that is saying that there are 2 hydrogens as well as 2 sulfurs. And so this subscript distributes to all of the things that are inside the parentheses. And so you can apply it to both. That is something that you may see every once in a while. All right, that's it for this week. Make sure to keep practicing balancing your equations and post on Canvas, and I'll see you next time. Bye.